Okay, okay. Hello. We're waiting for people to join our chat here and our Q&A streaming session. So um, while people come in, I would like to welcome all of the presenters and the contributors. And this is actually just a section of the source people. So hello to each and every one of you from all over Europe. Thanks for your contribution and for this great presentation. It was packed with information, and I'm sure there's plenty of questions. So I can see we have people from Foundry, from UPF. We have Disney, of course, DNEG, BUT, Trinity College, and the Saarland University. So it's pretty much everybody there. Yeah, that's wonderful. Yeah, while people come in, there were some questions on the YouTube chat, and I think there's a great question to start off with, and that was by Richard Levine. He asked, "What is the end game for Source?" Is the idea that it will be released for people to use, or a research program that people can use for reference in developing their own pipeline? It's a very manifold question because each partner handles that individually. So I think what I would do is get a quick statement from the order of the people that I see them from left to right, top to bottom. Dan Ring from Foundry, you're first. Do you want to comment on that?
Yes, sure. So I think possibly with Foundry's output, it's possibly quite easy. A lot of the work that's gone into come from Sauce on our side and gone into products has made it into the recent Flix version. So we actually have Sam Hudson on the line, who's the lead engineer for Flix. There was I think there'll be an exploitation report that'll come out soon, which should show some of the highlights. But in particular, there's like handling assets in a more efficient way, dealing with like kind of more assets, adding the ability to kind of add a plugin architecture for Flix to kind of make things smarter and more extensible. And we demonstrated with this with adding in extra formats, the ability to kind of classify assets as well. So a whole bunch of things that have gone in. So I think that's the main output from Foundry.
Thanks, Dan. David Marino, you're next in my list from UPF.
Yes, thank you. Well, regarding the UPF GTI works on source project, it will be all available online on the GitHub, and also the tools that we have implemented are very open. So yes, we believe that open data it's really important for us. So basically, that's it.
Good to know. Thanks, Heiko. You're next.
I'm Heiko from Disney Research Studios in Zurich, and as this project is still in the research phase, it cannot be determined yet what the outcomes are, and there isn't anything I can disclose at this time.
Thank you, Heiko. Mungo, you're next in my list. Maybe we can have the DNEG people in one block.
Yeah, sure. So I'm Mungo from DNEG. I was overseeing the crowd, the motion synthesis stuff. We had looked into early on in the research whether we could open source any of this stuff. The trouble was that we had so much original crowd animation format technology that we wanted to build on top of, and it would have meant open sourcing so much of the DNEG code base. So unfortunately, none of the motion synthesis stuff will be available. I'll pass over to Will about the other side of the DNEG work.
Yeah, I think we'll also end up with Henry as well after me. So there is a website that a number of the deliverables or outputs of the source project are available. So the actual research itself, I think, has huge amounts of value for anybody who's looking to do something similar. I think the work that we've done, has been incredibly valuable. I think I'll hand over to Henry. There was discussion. I think the overall discussion has been about how likely or if there would be a possibility that this would become an open source, or parts of it would become open source. And I think I'll let Henry comment on that one.
Yeah, so I'm the head of production technology at DNEG, just to give a bit of a sense of who I am. So as Mungo said, the technology related for the motion synthesis stuff is fairly tied to our internal tech. So it's unlikely we'd be able to do anything with that. Hopefully some of the information and buildables that we had will gain some insight into the approaches we took. In regard to the search and transformation framework, the stuff that Will and his team have been focusing on, that is slightly similar to Heiko. It's kind of open area of development and research. We're still trying to figure out exactly what parts, if any, we'll be able to open source. It is a fairly what we call a greenfield project on our side of it, so it's not specifically tied to our internal tech. So it is something that we are certainly keeping open. There's an aspect of that that we would like to support. We support open source in general, but it's a little bit early to say exactly what or to what degree we'll be able to open source the search framework.
Right, thank you to all the gentlemen from Double Negative. Marek, I have you next from BOT.
Good evening, everyone. The tools that have been developed for the source project at BOT will be made available for public online. The calibration algorithm is already available at SourceForge. The backend for it, this 1++ is also available. And GPU accelerated real-time refocusing method. The guys still want to publish a paper, and then the source code will be made available for public with it. So that is from us.
Thanks. So actually quite a lot of things. So TCD is next, David, Martin, and Pisut.
Hey, well, maybe I can start because I was also working on light fields. So I think also as a research group, our main output will be first a research paper where we can describe in detail the technical work, but we are also very much interested in publishing our tools and the codes for these tools. Some of them are already available, most of them online. Yeah, if David or Pisut wants to take over.
Yeah, I can talk next. So I guess, yeah, just echo what Martin said. So I mean, we've all done slightly different things in TCD. So we've been involved in some of the crowd retargeting work as well. And definitely a lot of the detail will be in publications and in the deliverable, but we're also looking at explicitly releasing the tools on GitHub. Because we're a research institute, it should be a lot easier for us. We just need to kind of package them up and make sure they're actually usable. So unfortunately, they're a little bit at the prototype stage at the moment, but once we've carried out an evaluation study recently, so hopefully we can make some changes, tidy it up a bit, and then hopefully release some GitHub links. And I can see they're going in the chat there for anyone who hasn't seen that, so that could be very useful.
Yeah, so for the skeleton tool, we developed separately from DNEG, so our part is already available for download, and we hope to continue working on this. There's some papers that related to us, and also their future integration with the KineFX. So we hope to continue to work on this and then publish more tools based on our initial work.
All right, thank you. Thorsten, I have you next.
Yeah. Okay. Hello, everyone. My name is Thorsten Herfet from Saarlandes University. We're the low-level guys in this project, so we've provided the array and the low-level tools, and this is why we haven't put up a suite that everyone can simply download because it's so specific to the array. But the good news is that we give all the support if you want to build your array. So nothing in the design of the array, including all layouts and PCBs, is secret. So you can get everything, but it would not make sense to put it simply onto the web because a lot of information and collaboration would be required. So if there's any interest in designing such an array by yourself, simply don't hesitate to drop us a mail, and we'll do our best to help you out and give you some insight in how we did it and what the tools are. As said, everything is open, but it would not make sense to just put it there because it's not a Lego thingy. It's a bit more complicated, so you would need advice from us anyhow.
Okay, thank you, Thorsten. So I also have Trevor, who is related to Universität Pompeu Fabra. Do you want to add to what David just said?
Yeah, sure. So coming from our group, most of our contributions are of the research type. So as I mentioned in the presentation, we have a number of publications describing each of the things that we did. As far as making the tools available, we have them in different stages of production. Most of them are a bit too early to say when or if they would come out, but our tone mapping tool we're currently doing alpha testing for, so we should have a product within the next year, I think, coming onto the market. So you can look to the color correction space for that.
Cool. And lastly, I have Jonas from Film Academy.
Yeah, thank you. We basically release all stuff that we developed in source publicly. We prepared, for example, 2 data packages that we put online, one containing light field elements, so basically short clips of light field material. We prepared for a large data set if you download that. And we also have a motion capturing database, basically a locomotion set that contains different styles of walking. So yeah, that is also available, for example, for machine learning. You can freely download that. And concerning our development of VPET, our virtual production editing tools, that is and always has been public. It is released as open source on GitHub. The link is already in the chat, and we also have, for the ease of use, we also released it in the Apple App Store, so you can directly download it there and use it as you wish. And there's also a version for Android available in the GitHub repository.
Yeah, well, thanks for that overview. I think it's obvious that I would say more than half of the research contribution is available, and then of course there's a lot of written material, right, that you can read up on all the publications. So here was a quite specific question for William Greenlee from DNEG, from Jonas Kluger. He wanted to know, how do you deal with missing terms in the Wordnet and Wiki databases? For example, Wordnet is very poor when it comes to VFX specific words and terms.
Yes, it's a good question, and it's interesting because, you know, within double negative, I think I've heard many people comment in a similar fashion. So one of the core parts of this project was, in particular, the search framework was around vocabularies, dictionaries, knowledge bases. This is a trend that exists, I think, in search systems and search engines, which has been going on for years, you know. And, you know, the visual effects space does have a lot of its own terminology. So I think there's 2 bits to this. One, which is, firstly, I think there's recognition that being able to use dictionaries is a good thing. So, you know, a lot of parties which I engaged with talked about having tagging systems and having their own classification systems, and inventing their own things. And really, I think the first statement is you don't need to do that. You really don't need to do that, and it's wasted time. In my opinion, this is one of the things which I think has come out of this project, which is useful. You know, don't waste time inventing things that other people have already spent a lot of time inventing. Now, if something's not perfect for you, and this is the case with any dictionary and any knowledge base, is that it's going to change. So being able to deal with the change is a second thing that you're going to need to be able to handle. I think the third thing, which is the framework itself, is about being able to leverage and extend knowledge bases and dictionaries and then align them with one another. So the really core bit, which I tried to emphasize in my presentation, was the use of some of these open standards. So in particular, web ontology language, SCOS is another good one. And there's a lot of effort that was done maybe 10 years ago by the W3C to provide the means by which taxonomies, vocabularies, dictionaries can be used and then extended and aligned with each other, because it was a fundamental principle of the World Wide Web and also the web of data. So this project just leverages that and tries to expose that a little bit more, in particular in this industry and in this sector, but also as a whole. And you know, it's one of the key, I think one of the key things that's come out of this is how easy it can be using some of these knowledge bases to start to get quite a lot of data and good data, which would otherwise be difficult to create in-house. Wikidata is a great example of this, where you've got all of Wikipedia, all of it available in a really good format, you know, a really rich data format with links to other things. And so, you know, this idea that you're going to have to create a knowledge base of films, you know, Iron Man, etc., you don't need to. They already exist. They're not going to be perfect, but the technology which has been advocated in this project, the RDF stack, the linked data stack, is all about dealing with disharmony of categorization of taxonomy of ontologies. It's about how do I harmonize those things together. So it's a method as well as a solution.
Cool, thank you very much. I posted a question. I've read your paper. I liked it. And yeah, I totally agree with like using existing data sets, but I used Wordnet like as a specific and like a practical approach, and it did not work. So yeah, Wikidata is way better, and I already added so many words for Wikidata. I think that's the way to go. Thank you, guys.
Okay, so I have a question for Martin Alain from TCD. So you were showing the light field refocusing tool in your presentation, and I was wondering if that is embedded in a standard software, or is that a standalone tool?
So we have different implementation of this tool. One of them is based on MATLAB. I know not everybody has MATLAB available, so I'm working on a C++ implementation at the moment that would include most of our tools together, and we'd be able to run the refocusing as a standalone.
Yeah, and then maybe to follow up on a bit more light field related questions, I was wondering maybe for Thorsten, but also Marek, do you have an opinion on how accessible the technology is right now, and what needs to happen to make it to get a broader use of it in more media productions?
I mean, Marek, if I may first. I mean, these things happen in relatively small steps, but we've seen in the recent, let's say, 3 to 4 years, we've have an enormous spread into amateur or semi-professional areas where you use all the algorithms and the ideas and the representations from light field formats in all the modern mobile phones, for example. Of course, it's still a bigger problem to do this professionally in an environment like ours with several 10, if not later more than 100 cameras. But I would assume that the learning curve that is now, or that people are now going by having this really in mass products like mobile phones, the improvements are so enormous, and they deal with 3, 4, 5 cameras there, that I'm absolutely sure that within the next 3, 4, 5 years, there will be possibilities to also have the algorithms ready to make use of rigs with more cameras, at least in fixed environments. So just imagine a virtual studio, the big green hells that you have at broadcasters, for example. DNEG also has some of those. This is fixed geometry. So putting like hundreds of cameras there is something which is on the horizon. with the same logic as all the computational photography that we've seen in the last 15 years, where the electronics has become mightier and mightier, and the lenses and the physics became correctable. So I have the feeling that we're now exactly in the phase where also the spirit, the math, the basic math really changed from just multi-view video to really understanding things like a set of rays, so like light fields, and this will really make a quantum step. But for professional production, this is not there tomorrow, so we'll most probably need a few more years. But everything in the environment that's happening now on the semi-professional and amateur market is very promising.
Marek, do you want to add to?
I agree with Thorsten. We at the university work with the light fields only in experimental state, but when the technology will be more widespread and when it will be integrated into some devices, it has a huge potential for multiple applications.
And compute power needs to be outsourced?
Oh yeah, of course, the compute power must be, there has to be a lot of acceleration, acceleration on GPUs, and that's the way how the algorithms will be able to work in real time or in a narrower time required for the task.
But honestly, that has always been the argument, right? And I mean, we're talking of arrays with hundreds of cameras. We're talking about a number of pixels or rays that's just 100 times as much. Actually, look onto the evolution of pixels in the last 15 years. So 100 is nothing mystic. It's something that happens within the next 5 years in compute power. So yes, we dealt with it in this project, and it was huge. And you remember our recordings where we had to store things, and we even could not cache it in real time, so had to make breaks in between. But I mean, these are things that I'm sure will go even faster than we think, and we're already the technicians.
Yeah, thanks for these opinions. Maybe one related question to that, Marek. The depth maps that you showcased in your presentation, what are their resolutions?
We worked with multiple data sets in our experiments. I think we mostly worked with the full HD resolution, 1920 times 1080. But we experimentally proved that the focus map does not need to be in a full resolution to achieve like really quality-wise, really close quality solution, like if we were using the full resolution focus map. So it was possible to use only half resolution focus map to reproduce quite high quality results.
All right, thank you. So I would like to get back to one of the questions from the YouTube chat by Jonas Kluge. And this one, I think, goes best to Heiko from Disney. He was wondering, how do you handle edge cases of categories with little training samples when training the machine learning classification models?
Okay, hi, that's another very good question. And these cases certainly can be very difficult to research upon. We developed algorithms that are more robust with respect to noise and also augment the data set when there are unbalanced data samples. And this basically boils down to a mixture of stratification and data augmentation. Stratification is about distributing the available data evenly across all of the cross-validation splits, so that you have in all of the training sets and test sets and different cross-validations with the same amounts. And the data augmentation is a mixture between 2D and 3D data generation. So depending on what modality we're working on, if it's videos, images, or 3D models, we can generate more data which follow the same distributions as the input samples. As this project is still in the research phase, it really depends on the specific use cases.
So let's get back to one of the other questions from the chat. Martin Eggert, he was asking for any connection to Houdini 18.5's new KineFX platform or plans of future implementation. He sees a lot of overlap. And I think there was actually people from DNEG, Mungo probably can answer to that. And also Pisut has an opinion or something to say, right?
Yeah, I can talk about this. So no, it doesn't have any relation. We started work on this a good couple of years ago, so that wasn't around. Also, part of the thought process around when we implement new functionality like this is we've been bitten in the past a little bit by building on top of third-party DCCs specifically, because it means that we are less able to pivot if another DCC comes along and replaces, we want to use it in the pipeline more fundamentally. So a lot of the processes when we were delving into this were around being able to write implementations for any DCC we want. So at the moment, all of our crowd work is done in Houdini, but there is still some layout tooling that we have in Maya. And with virtual production becoming more and more of a thing, it's very possible that we might go implement some front end for Unreal Engine. It also means that we can really dig into the low level memory management and CPU cycles to really optimize it for this specific technology. That's not to say that we wouldn't want to integrate with that in the future. We can, because once it's in Houdini, it's using Houdini's native data types. So anything that materializes in Houdini is using the crowd agent primitive. So it can integrate as and when there's a use case for it.
For Trinity College too, we just have a tiny bit small part of what the DNEG developed, and thanks to DNEG that let us join the project, and we develop it in a separate of what DNEG have been developing, and it's just by luck that because we built it, the tool that we built, the skeletons, we use the Houdini data structure, so just by luck that it's just compatible with the KineFX. So it's just a small part, but it works with KineFX. So we hope to develop further from that. There was a paper on the auto skeleton based on machine learning, and after the source project is over, we hope to. That's our next project. We want to implement, build upon that, and share with everyone.
Yeah, thanks, Mungo and Pisut. Maybe related to the crowd work, a question for David and also the tools and the accessibility. So David, your tools mostly run on the Medusa platform, which is a web platform. Are there any plans to port them to other tools or software platforms?
Well, in fact, we are currently porting the code to C++ and then to C#, so the core library could be inserted into Unity or into Unreal in the future, but right now it's not possible. But yeah, we have plans to integrate this into another platforms.
And maybe to stay within the affiliation, so for the color tools from Trevor, where do you best see your tools used in a production pipeline?
So different tools for different places. Like as I went through the presentation, it sort of goes through the pipeline from post-production or from production to distribution, but the majority of them are sort of distribution focused, since they are meant to be applied to images after they're mastered. So they're mostly just for adapting imagery, possibly even on the viewer device side. So that's where everything is kind of weighted towards in general, but the tools as a whole span the entire process.
All right, thank you. So one more question through the chat from Jonas Kluge. He was, any work done on data formats for achieving working with movie image files, like replacing AVIF for JPEG, any new approaches for movie files, question mark. Anybody wants to volunteer on that question? No.
Not sure I fully get the question, but we've been working quite a bit on how to store light field assets in a way that they can be used in standard workflows. And maybe the guy who asked the question is aware of the activities in MPEG-I, which is on light field coding, and JPEG Plano, which is on still image light field coding. We've participated to JPEG, and we also used still image formats like Adobe and OpenEXR to store them, because typically in contribution, so in the studio environment, you need very high quality representations, which obviously don't compress as much. But we have quite some experience and the tools there to use OpenEXR also for light field coding and exploit the compression techniques that are already built into OpenEXR. We, and maybe when Marek joins, also have looked into video codecs, but this is really more for the contribution or the streaming. So the quality that's achieved then, or you can achieve extremely high compression rates. What we have, for example, done is not defined an own coder, but what we've done is we've optimized the prediction by filling the prediction queues in HEVC. For example, you have a certain buffer for storing frames that you could use as candidates for prediction. And if you fill them in a very clever means, so that you really have all the temporal and spatial angular neighbors available, which have the highest correlation, then you can achieve a very good quality with an acceptable data rate. So these things are there. But in the studio environment, I feel that we would need something like either JPEG Plano or even professional formats like OpenEXR. The software that we have written to store the things in OpenEXR is available, but it's also in a, let's say, lab status. So it's available in MATLAB, so you cannot use it to in real time in code, but you can use it to explore how this is done, and then write some accelerated codes around it. So that's what comes into my mind. On video, it's like exploiting modern codes like HEVC. For studio environments where the quality needs to be extremely high, we would go for still image formats in the same spirit as JPEG 2000 has done it, and then storing things in, for example, OpenEXR or PSD.
Marek, you want to add? Or?
Yeah, if I may add, I'm not from the compression group, but I hope I will describe the work that we did correctly. So we try to extend the compression algorithms to the fourth dimension, like for the light field data. And we were evaluating this compression on data sets from LightRAW camera. It's like a very dense light field data, and from the camera rig from the USSR, from the university. And we achieved actually pretty nice compression results for the LightRAW camera, but for the camera rig RI, the compression wasn't much better than other existing algorithms, because the baseline between the cameras was too high to exploit the similarities in the old dimensions in the images.
Okay, cool. So yeah, I think we're coming slowly to the end of our Q&A session. So I have another question for Foundry, Dan. So with COVID-19 in mind, do you think that the use of cloud-based collaborative asset management will replace the local hard drives?
And we certainly see a strong move towards cloud over certainly the last year, but this is it had been happening, and COVID has certainly accelerated it. And I think a lot of the interesting work that we've been doing, as well as the work of DNEG, has highlighted the fact that assets and file, like we need to think beyond files, and assets is the way of doing that. And once you start doing that, it makes things like moving to the cloud and enabling remote work and all of that stuff a lot easier. So yes, I would say, yeah, COVID has certainly helped in that respect, in putting cloud kind of on the forefront of everybody's mind. Certainly if you're a freelancer that's starting up now, you have to think cloud. If you're a facility that's going to enable remote working, you're now probably forced to think about cloud. So yeah, and then assets are obviously the core of all of that, and being able to find and reuse them is absolutely going to be vital, as everybody here has demonstrated already.
Yeah, and I just wanted to add something there as well, is that with the introduction of Flix 6, with all of this work that we've introduced from the source work, is that's really enabled a lot of our customers to move over to the cloud. In previous versions, that wouldn't have been possible, whereas it now really is, and it's helped sort of kickstart people thinking about cloud. So it's been really great, actually.
So that probably also means that you're looking for a lot more smaller artist groups. So if I think about tools like Nuke or Katana, these are really like pro high-end, quite technical tools, right? But sounds like Flix is opening up to a whole new area of potential Foundry customers.
Yeah, I mean, it's a Flix, I suppose, is certainly a different market set. So like if Flix is more on the story development side, like storyboarding and paneling, and that's a different stage in production, obviously, with a different kind of user group. But I think one of the key things that Sam and his team have built is like the separation of the backend and storage part of Flix from how it's used. So we're already starting to look at Flix and its asset storage as a way for enabling machine learning on the cloud. So a completely unrelated separation, but it is that same kind of idea of not thinking in files, thinking assets, and then not just limiting it to Foundry software as well. So internally we are building currently on some of the things that we've learned in sauce on how to kind of enable kind of easier kind of migration and to the cloud, as well as enabling hybrid kind of cloud, like on-premise and cloud, as well as remote work operations. And that's not limited to Foundry software. That's just a sort of a project that, like, we realize everybody has to move to cloud. Like you can't just be an island of Nuke or Katana or Flix. Like everything, in a pipeline, there's lots of different software that sits together, and it's from high end to low end as well. So yeah, as well as already existing tools like Frame.io that live in the cloud already natively. So yeah, the goal is to play nice, and in order to play nice, you have to speak the same language. And we believe that asset is the language that we all need to speak.
All right, thank you, Dan. So yeah, that concludes pretty much the questions that I gathered from all the chats and different channels. Does anybody want to add final words to the group and guests? Well, then I would like to thank everybody for taking the time on this Monday evening to show off their great work. I'm really impressed. This is a fantastic project. It will come to an official end in 2 weeks by the end of the month. Yeah, we're looking forward on the final deliverables and the things that are available. Thank you very much for taking the time. In general, from my side, as having the FMX hat on, I would like to let you know that there is more FMX spotlights coming up early next year, and we hope to see you for the full online event next year, FMX 2021, Reimagine Tomorrow, which will take place in May 4th to May 6th. So greetings to everybody. Stay safe, stay healthy, and see you soon. Bye.
Thank you very much, Volker.
Thanks, Volker. Thanks, FMX. And thanks, everybody watching.